Hello everyone, thank you very much for the invitation to present today. We're excited to give you an update on our progress with Macrosystems EDDIE and how we are using our Shiny apps to teach ecological forecasting to undergraduates. My name is Tig Moore and I'm a postdoc at Virginia Tech working on developing educational models as part of the Macrosystems EDDIE team, which is led by Kaylin Carey with Quinn Thomas, and Whitney Wilmer is a PhD student who is also working on this project. Just a quick overview of today. I'll run through some of the background of Project EDDIE and Macrosystems EDDIE, give you some brief introduction to the materials that we've developed and how we've developed them, and then also discuss kind of priorities for FE's next steps. Ecological forecasting itself is an emergent field. We have discovered that generally education materials so far have been targeted towards PhD and master's students, and we are looking to build a bridge to introduce ecological forecasting into the undergraduate ecological curriculum. And we are going to do this by focusing on developing hands-on interactive materials that are approachable to both students and instructors. A bit of background on Project EDDIE. Project EDDIE stands for Environmental Data-Driven Inquiry and Exploration. It was formed in 2012 with the goal to develop a suite of online teaching modules. So far, Virginia Tech has received funding from the National Science Foundation and a total of 4 grants which have funded this work and are funding ongoing work. So an EDDIE module comes pre-packaged and ready to use. It includes instructor lesson plan, pre-class readings, in-class activities, homework questions with answer keys, and all of this material can be downloaded directly from the website and used as is or modified to fit a particular class need. And the overall learning objectives are to get students building data manipulation and analysis skills using real messy ecological data, using these data sets to build ecological understanding, and along the way developing data visualization and quantitative literacy. So Macrosystems EDDIE, which sits under the Project EDDIE umbrella, is focused on teaching local to continental scale ecology. And here at Virginia Tech, we've developed a suite of modules to bring these concepts into undergraduate classrooms. Through this project, we are building modules that challenge students to confront ecological complexity by incorporating drivers and responses across multiple scales while building quantitative skills through the R programming language and Shiny apps. Each Macrosystems EDDIE module is designed around specific student learning objectives that cover aspects of all 4 dimensions of ecology education. And we use the 4-dimensional ecology education, 4DEE framework. So within the modules, students learn core ecological concepts, they address systems thinking, are allowed to develop and test their own hypotheses about land use and climate change effects, and also gain computational skills through hands-on engagement with module materials. An important part of our program is that any module that you can find on our website, it has been rigorously tested with students across a range of classrooms across universities across the US and around the world. We assess students before and after the module, which allows us to measure students' growth. And a common finding across the classes is that students report an increase in proficiency and confidence using our software and ecosystem modeling. Here is a list of the modules within Macrosystems EDDIE. Modules 1 to 4 were developed on previous grants. Currently, we are developing modules 5 to 8 under the latest NSF grant. Module 5 has been developed and tested in 6 classrooms this last spring in undergraduate and graduate students. Module 8 has been developed by Whitney Wilmer and is currently in testing stages. Module 6 is in development and will be available for testing this fall, while Module 7 will be developed and ready for testing in spring 2022. So I mentioned in our Shiny app, but just to give you a bit more information on what exactly that is, they are interactive web pages built using R. The reason why we're using this is because we have found that it is less intimidating for students, but also for instructors who might not be as familiar with the R programming language. Students are able to choose their own adventure, complete tasks, and answer questions all within one interface. So one of the prompts for this talk was asking how we developed our resources. And just like forecasting, we found it to be an iterative process. First of all, we develop learning objectives are devised on a high level, and these are used to guide the lesson materials and structure. We identify the key concepts for the lesson and keeping them to a targeted number of around 3 to 5. we have a clear, unambiguous conceptual figure that will help us to map out the lesson structure and show where it overlaps with the concepts. We then explore kind of the NEON data and identify where it can be leveraged to integrate it cleanly and clearly into the module. Then digging into the workings of our Shiny and understanding how that can be used to enhance the student experience. And then a critical part is testing and feedback early on to kind of catch bugs, identify unclear segues or flag unintuitive figures, etc. And we have a host of undergraduates that we've hired here who have who work on testing these modules for us. So overall, it takes roughly about 2 months, kind of a full-time work to develop these modules, and then 1 to 2 semesters of testing, ideally about 5 different classes where you're collecting this pre and post module feedback and also getting feedback from instructors. So give you a bit more information in regards to module 5. It's Introduction to Ecological Forecasting is scaffolded into 3 parts, which allow for it to be taught either 1 3-hour lab or 2 to 3 1-hour classes. Students explore data from a NEON site, build a model to predict primary productivity, and then use this model to step through each stage of the forecast cycle. Each stage, they answer questions and then present the results to the group to lead discussion around each of the different steps. I'll drop the link into the chat, but this is the link so you can check out our Shiny app. So the module 8, which has been developed by Whitney Wilmer, using ecological forecast to guide decision making. This is structuring, kind of targeting, introducing students to identify the components of a structured decision, build understanding around how forecasting can affect, can be used to affect decision support, and giving them the freedom to kind of create visualizations tailored to specific stakeholders. The 2 other modules, which are module 6, which is still under development, and module 7 is coming next year, but they are focused around, module 6 focused on forecast uncertainty, quantifying contributions of different sources of uncertainty, looking at variations in uncertainty, and kind of looking and exploring the idea of predictability of ecosystem dynamics. While module 7 is introducing students to basic model data fusion techniques, where they kind of work on calibrating a model and look at kind of like using their model in under different scenarios and different climates. So some of the gaps that we've found is that introductory materials for kind of defining general concepts around uncertainty are not as kind of widely as available, or looking at kind of like a general summary of the common sources of uncertainty that might not necessarily be directly within ecological forecasting, and just kind of further examples of how forecasts are applied in resource management. So just to give a bit of background, module 5 was used in 3 different classes this past spring as part of the development to get students to build up to submitting a forecast to the FE NEON challenge. And we plan for this to be used in this role in the future. And if you're interested in joining Macrosystems EDDIE as a faculty tester for one or all of the modules this fall, we would love to hear from you and help you integrate Macrosystems EDDIE into your classroom or lab group in the future. And you can contact us with our emails, they're listed here. And I would just like to say thanks very much to the NSF for funding, personnel, my colleagues within Project EDDIE, the CERC team, and the module testers, and also the data providers, NEON, GLEON, LTR, USGS, and NOAA. And I will be happy to take any questions. Thank you.